left of a burn on the main stage. And then on the bottom right-hand side, you can see there is our speed. We're travelling at an unbelievable 7 kilometres per second, not per hour, per second. And on the top right-hand, you can see there is our trajectory. That is the planned trajectory, and the white cross is the position, the actual position.
Le pilotage est calme, la trajectoire est nominale.
Of the launch vehicle. Burning at the moment the main Vulcan engine. It's propelling the main stage, which is an extremely powerful beast.
Fin de propulsion de l'étage principal cryotechnique.
And we have switched off that
et séparation de l'EPC.
Engine, and we have separation there of the main stage, and we have switched on the engine now of the upper stage. So we're beginning the next phase of the flight. The
Premier
upper stage.
De l'étage à propergol stockable.
She's saying the first engine switch on of the upper stage. So the upper stage has taken the wheel, and its job is to transport our satellites to their correct orbit so that we can release them absolutely precisely onto their orbit, and from there they'll be heading off on their own in medium Earth orbit to their final slot, and they have to do that all by themselves. We have 3 orbits for anyone who's not familiar. Well, 3 main ones. We've got low Earth orbit, which is the nearest to Earth. We have medium Earth orbit, which is where these guys will be sitting, roughly 23,000 kilometers above our planet. And then we have an orbit called geostationary orbit. We're not using that one today, but that's where most of the telecommunications satellites sit, and that's 36,000 kilometers above Earth. The Galileo program is an important collaboration between ESA and the European Union.
A symbolic image at the European spaceport in Kourou, French Guiana, as the President of the European Commission, Jean-Claude Juncker, French President Emmanuel Macron, and the Director General of the European Space Agency, Johan Dietrich Voorne, stand in front of the Ariane V launcher, which will soon carry 4 more Galileo satellites into space. This launch will expand the Galileo constellation from 18 to 22 satellites. And it's the second time 4 satellites will be launched with an Ariane V. As with all other Galileo satellites, these newest additions will fly in a medium Earth orbit some 22,000 kilometers above the surface. This is the penultimate launch before completion of the Galileo constellation.
The completion of the constellation will take place in the summer of 2018, where we launch the last Ariane 5 with 4 satellites, which will bring the total up to 26 satellites. So we have at that moment 2 satellites in reserve, and we will then, after that, start putting some extra reserves in space in order to be prepared just in case.
Although the constellation is not yet complete, it's been in operation for almost a year since the European Commission announced initial services on the 15th of December 2016. These services were the first step towards full operational capability and a first opportunity for the Galileo system to prove its worth. Independent measurements since have shown that in terms of performance, Galileo is the best operating positioning system in the world.
We are having a better performance than our 3 competitors from the US, which is the well-known GPS system, the Russian GLONASS system, and the Chinese Baidu system. So of course in ESA we are excessively proud of this, and it is now important that we keep building on this performance and hopefully keep at the forefront of the developments.
However, the work on Galileo is far from over. The European Commission and ESA are already working on the next generation of Galileo satellites and infrastructure. They aim to continuously improve the system and explore the boundaries of technological possibilities, while trying to meet market demand with potential new applications or services.
A number of areas, for example, which are coming is the so-called Internet of Things. which will require positioning in sensors. And these sensors have very little power and very little battery capacity, so we need special signals for that, probably. And in addition, another area which is of interest is autonomous driving, where satellite navigation is going to be a very important component, but where it needs to be integrated with all sorts of other sensors in cars in order to make sure that autonomous driving becomes a reality.
With more launches to complete the constellation and set up redundancies, Galileo's performance and availability worldwide will continue to gradually improve, keeping Galileo at the cutting edge of satellite positioning technology. Today, the only publicly owned satellite navigation system has also proven to be the best.
And joining me here in the commentary box is Eddie Yao. Eddie is the ESA Galileo head of the System Engineering Unit. Eddie, it's a real pleasure to have you with us.
Thank you. It's a great time to be here. Thank you.
Just a very quick rundown of what you do and what does that mean?
Indeed. Within ESA Systems Engineering, we're responsible for the actual original design of the system and the flow down of the requirements, as ESA is the system design authority. As part of the system architecture, we make sure that the requirements are all properly flown down and released down there to the people for procurement.
So just back to today's flights, we had the signal, the tracking station in Santa Maria in the Azores picked up the signal during that film. Quick recap of the flight path, Eddie.
So at the moment, the launcher is flying up over the northeast across the Atlantic. It's passing over then the west coast of Europe, and then we'll go up over Russia, and then back down again over the southeast of Asia.
And the ground stations are picking up the signal from Ariane, which sends its signals down to those ground stations as it flies over. And that process is called telemetry. Galileo started offering services last year. She's telling us that everything's going perfectly normally. Just quickly, what are the main services, Eddie?
Indeed, actually, the initial services started December 2016. Over that period, we've been providing already the open service, pure service, and a search and rescue. And then, since then, in the 1st of July, the GSA has become responsible for the actual operations for the service availability.
Let's take a look now at the GSA.
The mission of the European GNSS Agency is to ensure that users in Europe and around the world get the most out of Europe's satellite navigation programs. To do this, one of the agency's key responsibilities is to oversee the operation and service provision of Galileo. In addition to our headquarters in Prague, the GSA manages a number of important Galileo service facilities and functions across Europe.
The GSA operations and service team works with a team of experts at several centers. The Galileo control centers monitor and control the constellation, working as mutual backups. The European GNSS Service Center operates the Galileo User Help Desk and supports users around the clock. The Galileo Reference Center provides independent monitoring of Galileo's performance and the quality of the signals in space. And the Galileo Integrated Logistics Support Center provides repair and spare part provisioning for the Galileo ground infrastructure.
The GSA also ensures that Galileo signals are secure, including the Galileo Public Regulated Service, which is reserved for institutional users. We are also responsible for the Galileo Security Monitoring Center and ensure the functioning of the EU GNSS Security Accreditation Board. The agency also plays a key role in the development of applications and services, manages EU-funded research, and analyzes the global GNSS market. As a result of our work, today many devices are Galileo-enabled and are already making a difference to users across the globe.
So Galileo satellites are making our positioning better and better.
Sont normaux, il reste moins de 2 minutes de propulsion de l'étage à propergol stockable.
She's telling us there's 2 minutes left, less than 2 minutes left on the upper stage burn engine. So the upper stage is indeed powering us. Its job is to deliver our satellites onto what we call a transfer orbit. And
La trajectoire reste nominale.
it's transferred because they will then travel afterwards on their own to their own final orbital slot. But the transfer orbit's roughly, I think, around about 23,000 kilometres. Eddie, how does Ariane know, how does the upper stage know what it's doing and where it's going?
Well, within the upper stage itself, there's actually an intelligence part to it. It's actually within what's called the vehicle equipment bay. It's more than just an onboard computer, it's actually a whole management system within the launcher itself. It analyses the information from the engines, from the propulsion, it has a navigation system, and it makes the decisions on what is the best outcome to achieve its mission.
So it's a very clever piece of kit, and it's getting ready right now to switch off the engine. The onboard computer will send the command to switch the engine off when the system senses the correct orientation of the launcher. So basically, the launcher has to be on track, it has to be going in the right direction, it has to be on time. The computer is programmed to understand that it has to fly from 0 to 19 minutes and 50 seconds. That will be the cut-off time. And it also has to be at the right altitude. Right now we are at 1,117 and climbing, travelling at 8.88 kilometers per second.
Première extinction de l'étage à propergol stockable.
So she's confirmed we have the engine has now switched itself off and we have entered the ballistic phase. Eddie, what does that mean?
The ballistic phase is basically when the launcher is travelling without propulsion. The rocket is travelling already high enough and fast enough to cruise without the engines being on. It's on a celestial autopilot, if you will. This will continue actually for more than 3 hours. What you also see is that the upper stage is going on a gentle rotation. This is what they call the barbecue mode. It's exposing each of the satellites gently for a brief period to the sun, just to keep the payloads and the satellites warm enough while it's in this barbecue mode and while it's in this transition. We saw the liftoff 21 minutes ago, and it would be great to see a few replays of that and that beautiful launch.
Nous sommes en phase balistique et la manœuvre d'orientation se poursuit nominalement. Top. Allumage Vulcain. Allumage des 2 EAP et décollage Ariane 240 Galileo Falcon 7. La propulsion est nominale.
Voilà donc, avec l'extinction de l'EPS, on vous le disait, on rentre dans une phase balistique, Cathy, une phase qui va être longue, plus de 3 heures, et on se retrouve tout de suite après.
Oui, absolument Thierry, nous allons, I'm suddenly finding myself talking in French. We're going to be coming back to you just before we switch the engine back on again in about 3 hours' time. So that will be 7 o'clock here in Kourou, that will be 10 o'clock at night in Europe. And what time in Paris?
23 heures pour Paris. À tout à l'heure.
11 p.m. in Paris. Bye.